Number 19. A resistor of resistance R is connected in parallel with a resistor of resistance 2R. The combination of resistors is connected to a cell. And we've got to work out what is the ratio of the power dissipated in resistor of resistance R to the power dissipated in resistor of resistance 2R. So with this one, we need an equation that talks to us about the power. And if you look at your formula sheets, we've got power is VI. We've also got power is I squared R, and we've also got power is V squared over R. So because these are in parallel, both this resistor here and this resistor here, they're both going to have a potential difference over them of V. So V is constant because they've both got the same potential difference, but because they've got different resistances, they're going to have different currents. So because they've got different currents, we want to avoid ones that have got current in there, and so that just leaves us with this one. So if we assume that the EMF of the cell is V, we can say that the power of this one is going to be V squared over R, and the power in our second one here is going to be V squared over 2R. So if we put those two equations together, V squared over R divided by V squared over 2R, and that's the same as multiplying by the inverse, so that gives me V squared over R times 2R over V squared. So my V squareds are going to cancel. We don't need to know about the resistance, so what that says is the power dissipated in R here is going to be twice as large as the power dissipated in this, and that's what you'd expect because this one's got twice the resistance, so it would only have half the current and for the same potential difference, so it's going to be half the amount of the power. So our answer is D.